If you're working with unlabeled peptides, you may find that your 2D proton-proton Noesy spectrum contains not just normal peaks, but also some peaks which are split into multiplets, like this one here. Now, this can cause a problem if you want to use your peak list as part of a structure calculation. The peak positions will of course be incorrect because they will be on these multiplet components rather than in the centre of the multiplet, which is of course where the chemical shift in your chemical shift list is likely to be. And also the peak heights and volumes will be split across these multiplet components rather than being counted together. So we've created a macro which will essentially replace each multiplet with a single peak at the centre of the multiplet, and where the heights and the volumes are the sums of the heights and volumes of the multiplet components. So you can start off simply by peak picking your spectrum as usual. You can of course assign peaks if you wish, so I'm going to use AP to bring up the peak assigner in this case and make an assignment. The multiplet peaks you will obviously need to create as multiplets. So you can see here I've used our multiplet peak picker and these have automatically been placed into a multiplet. You can access this peak picker through File, Preferences, and then in the Peaks tab. Alternatively, you can just pick the peaks separately and then right click and go to New Multiplet or use shortcut AM. It's worth noting that if you assign one peak within a multiplet, then the assignment will be carried over to the other peaks in that multiplet as well. Now we shouldn't forget that at the moment the peak volumes for these peaks haven't been calculated. So with Control A, or on a Mac it would be Command A, I'm going to select all the peaks in my spectrum and then right click and go to Estimate Current Peak Volumes, or we could use shortcut EC. And I'm going to estimate the volumes. Now all we need to do is run our macro, so go to the macro menu, run CcpN macros, and then create Noesy PeakList from multiplets. This brings up this little dialog box where we can select our Noesy PeakList that we want to use, and then I suggest putting all the peaks into a new peak list. Let's have a look at these. So you can see here is my original peak list, which contains 3 peaks. My new peak list now only contains 2 peaks. And if we have a look at the multiplet peak list, then you can see here this multiplet has positions which are the average of the peak positions. The height and the volume are the sums of the height and the volumes of these, and these are then the height and volume and the position which have been assigned to this peak up here. So this new peak list is now one which we can use in our structure calculation.